the ball at A is kicked such that the angle of the projectile, it is 30 degree, and this angle is 30 degrees. Okay, if it strikes the ground at point B, and let me show you, this is the reference axis, and this is my y direction, this is my x direction, and the location has been written down as, you can write down location throughout the layout of the reference page. So this is the point location. Point B is located x minus y, and what is x? X equals to 15 feet. So B, let me write down, B is 15 feet is x, and negative 9 because it is below the x axis, that's why it is negative 9. And determine the speed at which it is kicked and the speed at which it strikes the ground, or the landing speed. So we have to find out initial speed and the landing speed. So okay, remember, as I mentioned many times, during the flight you have two components of velocity, and we have to find out VA. So using those two components, so VA equals to VAX square plus VAY square, and similarly VB equals to VBX squared and VBY square. And after we know these magnitude formula, let's start using how can we find out the VAX. Okay, yes, let's use the distance formula in the x direction. So x direction, the distance formula in the x direction, this is x equals to x naught plus v, actually naught means the initial speed, VAX times t a to b, with the acceleration component being 0, because the velocity in the x direction, this is always constant. That's why I have mentioned this many times. So this is xb. Let's plug in all the values in this equation and find out the unknowns. 15 equals to 0 plus VA, which is VA cosine 30 times t from A to B. Let's use t without sub because we know this is time of flight. Now we have two unknowns in one equation. Now let's use the same distance formula, but now in the y direction. That will solve probably many unknowns, but let's try. Okay, let's try use the same equations, distance formula in the y direction. YB equals to YA plus VAY times of time the flight, and negative 1/2 g times t square. And let's see, is g the SI system or FPS system? This is FPS system, so g in FPS system, it is 32.2. So this is the second. Let's plug in the values. What is YB? If you closely look, this is negative 9. Agreed? And YA is 0 plus VA sine 30. Agreed? Now time of flight is the same, minus 1/2 32.2 times t square. So now we have, this is equation number 2. So when you have two equations, two unknowns, what I would suggest, you plug in time from there to this equation. Replace time from here. I would say 15 divided by VA cosine 30. That way you will plug in time over here. That way you will have one variable in equation 2 and one unknown. And if you solve for this, since I'm not solving to save time, I'm just writing down the answer from my notes. 16.5 feet per second, and time t equals to 1.047 seconds. So so now let's do the what if we know the magnitude. This is the magnitude, okay? The magnitude, if you already know. So what is VAX? That is equal to VA cosine 30. Since the projectile angle is 30 degrees, so we can plug it in 30. So if I do the math here, 16.5 times cosine 30. Okay, so what is that equals? This is 14.3 almost. Okay, and this is the same. This is the same constant velocity in the x direction. Okay, in the same x direction. So VAX equals to VBX. Let's write it down as 14.3 feet per second. Now we are glad that we have found the component VBX. Let's find out VAY from the formula, final velocity formula. So that is much easier for me to write it down. VBY equals to V initial negative GT, where T is already there. So let me plug in the equation, everything here. So VAY, so VBY, which is the final velocity at the landing point, which is and VAY, which is 16.5 times sine 30, negative 32.2 times 1.047. If you solve for this, you should get negative 25.45. And it is obvious that it is the landing velocity component in the y direction, and which is in the downward direction. That's why we have a negative sign over here, because the landing speed is, this is the downward direction and this is the VBX. So it is intuitively, this is also making sense. And now finally the magnitude formula. If you plug in this in the magnitude formula, what you should get here, you should get 29.2 feet per second. This is 9. Okay, so this is our final answer. Thank you.